Okay, welcome back. In the last video, we're looking at the Tecno LP problem. This is just a continuation. We looked at how to run the sensitivity report in Microsoft Excel. In this video, we're back in Google Sheets. We have updated the sensitivity report here, so we just basically copied and pasted over here. What I'm quickly going to do now is just run this model to make sure that everything looks fine, and then we have our minimum cost showing up here, right? So I'm going to run the model. I'd already inputted everything here, and we're expecting, I think, 8.25 million. And then we're also going to observe what happens in our decision variables right here. Good. Yes. So we do have the total cost to be 8.25 million, and then we have our decision variables here, right? Before we even get to sensitivity analysis, we need to tackle a couple of questions. So the first question was a non-sensitivity analysis question. It was just a question about profit. So I've expanded this, and let me display the answer. So I'm quickly going to go through that. You've been given the revenue, you've been given production costs, and it's asking you to calculate the gross profit, right? So in order to do that, we need to first figure out the total number of units, which we can easily get by summing all these up. The demand from each wholesaler, when we sum them up, that's going to give us the total number of units. The total revenue is going to be the revenue per unit times the total number of units. Production cost is going to be similar. The production cost per unit times the number of units. And then we can also get the total delivery cost from the solution of our LP problem, which is right here. All right, so the production cost and the delivery or the transportation cost, these two are going to give us our total cost, right? And to eventually get the profit, we're going to just subtract the total cost from the total revenue. That's going to give us our overall profit of around 3.56 million francs, right? So that's it with the first part of the question. Now, to look at the second, third, and fourth questions, we need to understand the sensitivity report that's been generated. So what I'm going to quickly do is I'm going to snap these two together. I'm going to duplicate this so we can look at them side by side. All right, so let's look at our LP solution. Let me reduce this to around 100%. We're looking at the LP solution, and we're also going to look at the sensitivity analysis in another window. So let's start with the variable cells. I've highlighted this green so we know that this is talking about our decision variables. This sensitivity report is specific to our decision variables. This sensitivity report is specific to our constraints, right? So we'll come to the constraints later. Let's start with the decision variables sensitivity report. We want to start looking at final value. So there's already a video on ALUX that describes all this, so I'm not going to go through that in depth, right? So I'm just going to quickly tell you that final value is the same as the decision variables you're getting over here. So for example, plant 1 to warehouse J, the number of units we have to send from that plant to that warehouse, 0 in this case. It also shows that it's 0 here, right? If you're looking at something like plant 2 to warehouse J, 4,500 is also 4,500 over here. Plant 2 to warehouse N, 3,000. Plant 2 to warehouse N, 3,000. So realize that this sensitivity report tallies with what we have over here, right? We're going to come to objective coefficient. So the objective coefficient is basically what you're also seeing over here. So these are the coefficients in our objective function, right? So the cost per unit from plant 2 to warehouse L is 500. We also realize that plant 2 to warehouse L is 500. So it just replicates that for you, so on and so forth. Now let's come to allowable increase and allowable decrease, right? So what allowable increase is saying is that how much can we increase this objective coefficient and our optimal solution still remains the same, right? Allowable decrease is how much can we decrease this and our optimal solution still remains the same. Right, I'll come to reduce cost when we're looking at the other questions. Right, the explanations are in the video I talked about, which is on ALUX. So let's quickly start answering these questions. I'm going to minimize this and re-expand this. Let's look at question 2. So question 2 says, how much will the cost of delivery between plant 2 and wholesaler M need to change in order for the optimal solution to change? Right, let me review this answer. Right, so In order to understand how much the cost of delivery between plant 2 and wholesaler M needs to change, we need to look at something called the allowable increase and allowable decrease, which I just explained. Right, so let's look at plant 2 warehouse M. So I'm expanding this. Let me come to 150%. So we're looking at plant 2 warehouse M, which is here. So let me just highlight this entire area. So we need to figure out how much we can increase that and how much we can decrease that in order for the optimal solution to start changing, right? So what this means is that once we go beyond our allowable increase and our allowable decrease, once we go maybe below a 50 decrease, that means the optimal solution is going to change. So that's what our answer is going to be. We'd have to look at the allowable increase and allowable decrease for the variable plant 2 warehouse M. This can be gotten from the variable table in the sensitivity report, right? So for plant 2 warehouse M, the answer is going to be the allowable increase is infinity and the allowable decrease is 50. In maybe the last video, I'm just going to confirm all these things by rerunning the LP solution by changing some of these things to confirm what we are seeing in the sensitivity report, right? Now let's quickly move on to question 3. Now question 3, I want you to forget about this. I'll come to that later. Now, what question 3 is asking is, for every additional phone required by wholesaler M, how much should the total cost increase by? So in this case, we're not looking at plant 2 to wholesaler M. We're just looking at wholesaler M. So when we're looking at wholesaler M, this is wholesaler M, we are looking at the constraint, right? So for every additional phone required by wholesaler M, how much should the total cost increase by? And this is when we're going to start looking at our constraint table, right? So let me reveal the answer. The answer is, to answer this question, we have to focus on the shadow price, right? So basically what the shadow price is telling us is how much of an increase am I going to see if I increase my demand by 1 more unit, right? So if I increase wholesaler M to 8,001 units, so I've increased it by 1 more unit, how much is this cost going to change, right? So what this is telling you is that, so for wholesaler M, anytime I increase my demand by 1 unit, so if I'm saying that wholesaler M says they want to now they are now demanding 8,001 units, my total cost is going to increase by 650 Rwandan francs, right? And in the next video we're going to confirm that, right? But in this, so we see that in the answer is saying for wholesaler M, the shadow price is 650. So for every additional phone unit required by wholesaler M, the total cost would increase by 650. So we're done with question 3. Let's finally move on to question 4. Question 4 is saying, if the demand at wholesaler K was increased by 4,000 units, how would that affect the model, right? So let's reveal the answer here too. So our model will be affected by an increase in the total cost, the same way we're looking at it in question 3. The wholesaler K is talking about the constraint in wholesaler K. If we're going to increase this, because the demand currently is 6,000 units, if we want to increase it by 4,000 units, that means wholesaler K is now demanding 10,000 units. What's going to happen to our model, right? We know that if we're looking at the shadow price for wholesaler K, it's saying that for every increase in the demand, we're going to have an increase of 350 in the total cost, right? But in this case, we're increasing it by 4,000 units. We're going to multiply that 4,000 by that shadow price. So this is going to be the total increase in our transportation cost, right? So therefore, our total transportation cost, this is transportation cost, is going to be 8,250,000, which is the current total cost, plus this additional 1.4 million. So we're going to have 9.65 million Rwandan francs, right? So these are the answers to the sensitivity analysis questions in our LP problem for Tecno. I might do one last video, which is just going to confirm all these interpretations we have made from the sensitivity report. So for example, for question 4, we're going to change this to 10,000 units, right? Rerun the model and see whether we're going to get 9.65 million over here, right? So the whole point of the sensitivity report is that we don't need to always rerun the model, right? Once we look at sensitivity reports, we can answer very quick questions on if this increases by this, how much is what's going to happen to my model, what's going to happen to my transportation cost, etc., etc., right? But we're just going to use maybe the last video just to confirm some of these things.